Yeah, I was ranting for a while until I realized that my video wasn't recording. So I want to talk about the OSI model, which is a very foundational topic as it relates to networking. It always comes about in the CCNA, and it always something that every network engineer needs to understand. So the OSI model, or Open System Intercommunication Model, is basically a model that shows how how data is being transferred to each other um, through seven distinctive layers. Now, I made this description where I basically tried to explain a lot of things, but I realized that almost my um, video wasn't recording. But I'm going to explain it again, but I need to get into some things quickly. So at the layer 7, we have the application layer. This is the layer that we interact with. For example, we have paint here. So if I open paint, I can basically interact with paint here. I can basically do what I need to do in paint. This is the layer that users usually interact with. And then below that, we have the presentation layer. This is a layer that is that allows the user to basically um, create. It basically creates the compression and encryption and decryption. It's like this is where your .zip files come from. This is where your .exe comes from. At a level in which it can be presented. But when you are downloading a file, and you're finished downloading, the thing would say .exe, .zip, and this is also the part where we usually come towards encryption and decryption. So this is your secure shell, that's your SSL. I mean, so you get SSH, your secure socket layer, SSL, your TLS. This is where they usually come into play. And then we have the session layer. This is basically like where it's a layer that maintains user connection between two devices. So in this thing here, in this the diagram here, the server is being connected to the PC. So it has a certain time. The thing is that session layer has a certain time to which it basically like interacts with or communicates with a device or a server, but before it's being cut off. So that's why when you basically go into a website and you don't interact with it for a while, it will tell you that, oh, your session have timed out, please connect to the website again or try again, like something like that. This is the session layer. This is the layer that handles that. Then we have the and within the session layer, sorry, we have the web tokens, cookies, the things that handle user authentication and stuff. The user authentication, user session. This is where your session token comes in, your JWT and stuff. That's your JSON web token. This is where they usually come into play. Next is the transport layer, which is the layer 4. The transport layer is basically the layer that creates a secure channel in which data is being sent. Data is being split into different, like into smaller pieces, like packets of data is being broken down into multiple segments and then transferred into a secure channel, either a secure channel or a non-secure channel, or like it basically like transports your packets of data, the data that has been broken into pieces from one device to another. And there below that we have examples of transport layer include like the TCP, your UDP, your DNS, your HTTP, and that's where it is. Now for the layer 3, this is the network layer. This is the layer that has to deal with routing. Basically, it's the way network communicates with each other and how they, like, it's basically like pre-preparation for transporting packets. It handles like data. What it does is that it handles data transfer between two devices, like let's say between one router here and another router here. So it basically handles those device, like, you know, it basically handles those data, like the data communicating between those two devices. And this is where your IP comes into play. Internet protocol. Yeah, that's where your IP address comes into play. Do you know, for in order for the device, two or more devices to communicate to each other, you need an IP address. The IP address is used as a way for the device at the network layer to basically speak to each other, so that the data that they are sharing to each other will not get lost in transit. And this is where routing algorithms come into play, like OSPF, BGP, EIGRP, and stuff like that. This is where your routing protocol comes into play. Now we have the data link. This is where your switches and also in some cases your routers are. This is where the place that allows your the two or more devices to communicate with each other for at the lowest level. Basically, your MAC addresses. This is where your MAC addresses, sit on, and this is where if you want to like communicate via data link, this is where your ARP comes into play. Your ARP and this is where your ARP, address resolution protocol, this is where it comes into play. So it's basically like the bare bones of networking. Like it's the bare, like the lowest when it comes to like communication between devices, at the lowest, because the apart from getting the IP address, the device must also need to obtain the MAC address of the device is sending the information to. And also the layer I want to say something. At the layer 3, this is where you like your handshake, your TCP/IP handshake comes into play. Now the physical layer is the physical device where all this happens, from layer 2 to layer 7. This where this your routers, your cables, your physical switches and stuff like that. This is where it all happens, your fiber optics and stuff like that. So now let's use an example. Let's say there's this server here that has like an image. This image, he now wants to send it to this PC here. The first thing it will do is that, or sometimes in some cases, let's say this is an app, and then the PC, the first thing it will do is that it will ensure communication between the server and the PC. This is where your layer 6 and layer 5 come into play. Your server basically tells the PC that, hey, I want to send this stuff to you. Would you agree? If the PC says yes, then it will ensure a communication line. This is where your session layer and your presentation layer comes into play. So the server will generate something like a TLS certificate or a secure shell or a secure layer in which it will be able to like connect to the PC. That's why when you type into SSH and the IP of like the device that you want to connect to, and you put in the password, this where the password is layer 6. This handles user authentication, and once the user is logged in, layer 5 now comes into play. This is where the session layer now comes into play. This is where SSH now maintains connection between the server and the PC. And if you don't use SSH for a very period of time, it will time out, and then you will now have to do the whole thing all over again. But let's continue. So let's say the connection is already set up now. The server will now send let's say the entirety of this image now is 12 bytes. The server will now send the 12 bytes to the router that, hey router, this image has 12 bytes. So, and then the router will now like send, this one is at layer 3 and layer 4. This is where layer 3 and layer 4 comes into play. So the server would send information to the router. The router will then break these 12 bytes into smaller pieces. That's why when you download, you would see all those like progress bar and stuff that it will be showing all these things. So let's just minimize this for now. It will break these 12 bytes into smaller pieces, and it will now send them into smaller segments. This 12 bytes packet, it will break it into 4 bytes, and then it will now send it will now create a layer like this, where layer 3, layer 4, layer 3 and layer 2 comes into play. Layer 4, layer 3 and layer 2. The router would first send a TCP handshake to the second router. If it acknowledges it, it will get the IP address of this router 1 as well as the MAC address, and then it will send those packets to router 1. Router 1 will now send those packets from router 1 to the switch. This is where it will now deal with L1, L2 packets, layer 1 and layer 2 packets, and then the switch will now send those 12 bytes down to the PC, and then the PC would it will send the packet. What router 1 will do is that it would get those packets that has been sent by router 2, combine them together, put them into 12 bytes, and then send it to PC to the PC here. And once that is done, it will then cut off the connection and that's if its work is done. But if its work is not done, it can still like maintain the connection and stuff, but it will cut off the connection, and then the PC will get what it wants, the picture, the image that it wants. So this is the image that it wants. This is the image that is how the whole thing works. So that's all I have to say for the OSI model, and I think I am done. Thank you all for listening.